Okay, it took a long time to respond, and maybe it was a waste of time, but hopefully it was helpful for the guy. So, back to where we were. Only an hour left, but I was 10 minutes in, so whatever. Hour and ten for this. Okay. This is too loud. Yeah, so it seems like const expression functions and const eval functions are almost, special, because compared to non-const expression, non-const eval functions, if they have local variables that aren't const, they can't pass those variables as arguments to const expression, const eval functions that require const expression values passed to them. But because const expression functions, when the variables that they create aren't actually stored anywhere in memory, they're just local. Well, yeah, if it's executed at compile, you could also execute it at runtime, I guess, too. But if it's const eval, it won't be. So if we assume that they're actually executed at compile time, then you're not using any memory to store shit anywhere, meaning that sure, those variables are created and instantiated in memory, but really they're just values that are being moved around. And those values eventually yield results that are just substituted into the code and into the binary and the translation unit. Or at least into the compilation unit, and those values are then used by actual runtime calls during the translation unit. Or I guess the translation unit is compilation, so that's before runtime, but used in the translation unit for runtime. All it said, things that execute at compile time can create local variables that aren't even const, but they're ran at compile time, so the compiler sees everything that's going on. Which means that they can get passed to other shit that the compiler is doing. Yeah, the value of everything must be known to the compiler. C++ allows these to be known because it's executed at compile time. Gotcha. Even though those values aren't const expressions. Because they're compile time values. So we're calling foo with 5. We're calling a const expression function, or a const expression returning, or a const expression integer returning function. With this argument that's not a const expression. So we're calling it, but we still have to call it with a const expression value, which is in this case an integer literal. And it then returns the return value of a call to goo, passing in what it got. Well, this might not be used. This might not be called at compiled time because it's not required in this case, but it might be. But when it but if it was the weird part here is this isn't necessarily resolved at compile time. If this was const eval, I could see it. I guess we're saying in this case that, hey, this value is a const expression. It's passed here, so this guy is using const expressions, therefore it's probably running at compile time. Therefore, it can pass its values inside it that aren't necessarily const expressions to another const expression function that will only accept const expression values. at least if it was const eval, but in this case, same thing because it's being evaluated at compile time, so it's basically a const eval. And it will then return C here, which is whatever it got. So we're passing 5, passes 5, returns 5, returns 5. Yeah, foo may or may not, yep. If it is, then the compiler knows that B is 5, so it's okay to pass B here. And because this const expression function is evaluated at compile time, anything it calls is evaluated at compile time. It's now const expression because this is evaluated at this is evaluated at compile time because this is. If this isn't, this doesn't necessarily have to be either. So it knows, hey, 5. Okay, it knows 5, it knows 5, it knows 5. It knows whatever the value is. Even if it gets changed to 6 and then passed, it's still okay because it knows, because it's evaluated at compile time. The compiler is the one with the cards, so it can do whatever it wants with them. It's at runtime where things get wonk. I'm basically thinking of it like, hey, here's a function. If the function is being treated as a compile time function, so it's evaluated at compile time, it kills any identifiers and replaces them with value. So it's calling goo with 5. Goo is also evaluated at compile time, so it's saying, oh, integer 5, return 5. Okay, return 5. Okay, 5. Output 5. Makes sense, because, or hold on, here we go. Yep. And if it is, if it's instead resolved at runtime, then it's also runtime. Can a const expression function call a non-const expression function? Probably depends on a few things, maybe. If the const expression function is executed at runtime, then yeah, sure, because everything's at runtime. If it's required to be executed at compile time, then it might depend on whether the compiler decides if that function can evaluate at compile time. If it cannot, then it might just actually give you an error. So maybe it's only possible when it's runtime? Yep, exactly. It's exactly what I thought right there. That's good. Yes, but only when it's used in runtime context, basically. Yep, it can't be called if it's evaluated at... Yeah. Yeah, because if we call a regular runtime function, sure, the compiler might execute it at compile time, but it's not required to. Even if it's used in a context that requires it of a const expression function, meaning I'm using a const expression function to initialize a const expression variable, which means that everything in the const expression function must be evaluatable at compile time. But it will only force things to evaluate at compile time if it can, which means a const expression function can be forced to evaluate at compile time. But the optimizer is what determines whether a runtime, a non-const expression function will. So it's not going to force a non-const expression function to. So it kind of just depends on, it depends on how the calls are working, the context that it's called in. God, if I was reading this on day one, holy shit, dude. Hold on. Oh, I guess it's not returning anything. Oh. Hold on. I don't know if this is an IDE safety thing or not. I'm just calling this to get a variable or to get a result that I'm going to discard. I'm not initializing anything that's const expression, so this do thing shouldn't be evaluating at compile time. Which means it should be evaluating at runtime, which means foo that evaluates at runtime should also be evaluating at runtime. Seems like there's semantics I don't really care too much about right now. Yep. Yeah, so doesn't this mean... Guess we don't care. If we compare this... Yeah, I'm calling this guy, and it's returning a non-const expression function. It's legal as long as some function isn't called in a const expression. Well, the problem here is that... Is it saying that here? Ah. Gotcha, which is why it included both of those. Okay, so we could also have const expression foo. Hold on. Goo. Sure, and then I can just do... Or we can say... I could say sure, I guess. What? Hmm. Okay. The reason why it wasn't working earlier is that const expression functions must at least return a const expression value in some path. That way it can 100% be executed at compile time, at least in some cases. In this case, we're passing 3. Oh, in this case, it's not required to execute. So even though this is a const expression value, it's still executing at runtime here because it's not required. But I could do const expression int test, and I initialize it, excuse me, to be the return value of do thing path. But the problem is we need it to be, actually, yeah, this should be maybe okay. Hold on. What's happening here? Yeah, it makes sense. Can't do that in this case, so we actually just have to say 3. And then we're fine. Cool. Okay. The issue there was that main, this value isn't necessarily known at compile time, so we can't use this in the call to a const expression value. We could if that variable is created in the const expression variable, or in the const expression function, but main is not a const expression function. Okay. Yeah, I almost wish that this was said earlier, but I guess it makes sense that it's said after. It's like, he'll let you fuck up, and then like, hey, this is why it fucked up, by the way. Like, hey, I saw you hammering the nail that way, but by the way, these nails are really brittle. That's why they were breaking. So, cool. That's why it at least needs a way to return a const expression value in some context. Yep. Const expression function is ill-formed if it doesn't return a const expression value for at least one set of arguments, because it can never actually be called at compile time, so it shouldn't be const expression. It may as well just be const. Calling a non-const expression function unconditionally makes it a form. Yeah, makes sense, because it can't be called at compile time. They're not required. Well, we get one. Well, yeah, that's exactly what I did. They're not required, therefore it won't complain. Hold on. Well, I guess I have a high warning level too. Well, let me verify that. Hold on. Warning level's 4. I think it's only second to all. Yeah, it's pretty high. Does it say anything? No. Oh, well, it actually, yeah, it did complain, even though I didn't call it in a constant context. If you call it in a constant context, then it'll say, hey, you're trying to call a non-const expression function, i.e. a runtime function, or at least a function that is likely to execute at runtime and not at compile time, in a const expression function that must evaluate at compile time. Therefore, the const expression function can't evaluate at compile time. Error. But in our case, I wasn't doing that. I was just calling it in a non-const expression context, non-compile time context. So it should have just been ill-formed and been okay, and it called the non-const expression function with inside it. But instead, I guess I get the extra warning, and it's saying, "Hey, buddy, your shit is ill-formed." Gotcha. So in C++23, it's actually less safe, it seems like, in terms of errors. It'll say, hey, you have a const expression function, and in all contexts, it's calling a non-const expression function that can't be called at compile time or isn't guaranteed to be evaluated at compile time. Why is your function const expression? It shouldn't be. Avoid calling non-const expression functions from const expression functions. Why? Because it isn't guaranteed that it's going to evaluate at compile time. So if you're using a const expression function, it's probably the case that, I mean, you might even be using static asserts in there too, which require evaluating stuff at compile time. So it's probably the case that you want everything in a const expression function to be evaluated at compile time. Like maybe I pass a map, and a map is a huge array, I guess, or list of vectors, all these different positions in the whole world. And at each position, the shading should look like this. So we're generating a whole fuck ton of data about all of those, and we want that to be done at compile time. So I compile and it takes 20 minutes. But afterwards, the game runs flawlessly because all that information can just be pulled in and pulled out as needed, and it doesn't need to be calculated. It's just pulled into memory and pulled out. Just like I'm assigning value to something and then I'm removing it so that it can be assigned something else, or that memory can be freed so that some whole different variable can be put there for safety. Like if I'm in one particular part of the map and we're not loading other parts, well, maybe I can remove the other parts from memory, and then when I go get over there, I can remove these things from memory, this shader data, and then input that shader data, something like that. Like if we had a buffer, and if I say that a buffer is a segment of memory with stuff that's written in there, I have the shader buffer, but it only has enough room for where we are in the game. Well, I want it to be able to change and put it and remove shit from where we aren't, and then put shit from where we are into the buffer. And then it can remove that and then add in new stuff as we move around the map dynamically. But all that information is still stored somewhere. That way we could just pass it in. We don't have to actually do the calculations for everything. Because then when you get in the room, it has to determine what all the stuff should be instead of just pulling in what it should be. Because those calculations are where the costs are, I think. I'm guessing. Man, this function. Okay. My video is probably going to get copyrighted for accidentally watching that much of the song. Fuck. This part is the most important and makes sense. Well, yeah, I mean, you have to do some shit at runtime. That's why you can't do const expression for every function. I mean, a lot of information is probably determined in the. Well, I mean, like, you could do const expression functions to determine AI behavior, I guess. Like, you could calculate all the possibilities or something and store that somewhere. So you could initialize like a big list of all the possibilities, or or like maybe at compile time you generate a sequence of all the moves an enemy's gonna do. So it's random and it's calculated beforehand. That way you don't have to calculate everything intensively while at runtime, which is probably fine. But You can do it beforehand to make it cheaper, maybe. And then you store that somewhere, and so you have all these moves. So it's going to do this, and it's going to do that, and it's gonna, well, I guess it's totally ignoring what the player is going to do. But let's just pretend like that. Let's say it's like China was going to behave as it is in Civilization or something. No matter what the player did, it's just going to do this. It's fine. So at compile time, you could run this function that's very expensive that calculates all of that information. And maybe you have one function that calls another, and it has a loop. The first function, the constexpr function, has a loop that runs this other constexpr function a bunch, and each time it updates this value and this and this and this and this, or it keeps appending new values onto this list of this huge sequence of all the moves that the enemy is going to do. And at compile time, it assigns this to some global variable. Now, the global variable at runtime has all the information calculated. It has all the angles and all the craziness. Maybe there are a bunch of different values, a bunch of different stuff. And it's random every time or something like that. Then, at runtime, you can access that value that was expensively calculated at compile time without having to do the expensive calculations at runtime. Okay. Wonder why that is in games. Why you have to load shaders. I mean, maybe that's a process of passing information. It's not actually calculating the shaders, maybe. Maybe it's just a process of passing that information to the graphics card. I don't know how graphics cards really work. I don't know if they have memory. I mean, what do they have? CPUs have gigahertz and frequencies and shit. I guess the amount of things that they can do in a second or in some unit of time. A graphics card, I mean, it processes things. So is it that the information is all actually already in there in the COD files, and that's why it's 100 gigs? And it just takes a while to pass 20 gigs of information. Let's say 60 gigs is the map shit and all the logic and stuff in the game, but then 40% is just shader and graphics information. Maybe it just takes a while to pass all that information to the graphics card. That way the graphics card can, I guess, store it or something? Or like pre-process it so it's like warmed up, like it's in its mind. Like if I came into a room and someone wanted me to remember 10 words, it might take a while. The words are already on paper, sure, but you can't just give me the paper. You have to fucking warm my ass up and test me on the paper so I know, okay, that shit's in my head. That way I can draw the symbols at will, because you don't have arms and you need me to draw symbols. You're the processor, you can't render the graphics, I have to do it. But in doing so, you have to make sure that I know all the information. You have the info, but you have to pass it to me. I'm not sure what the compiling part is, and Black Ops is like the only game I've ever even seen that does this. Black Ops 6, where it takes like 5 to 20 minutes just to compile shaders. And I'm curious why that isn't a one-time process, why it isn't just compiled or stored in memory, and then it's just done. You run the game and boom, you're good to go. It seems like it's already in memory maybe, or it's already in the code, and when you execute it, that information has to be passed to whatever piece of hardware you have that actually uses the info. And so the question is if the hardware can store that information, or I'm not sure what the process is there, but okay. It seems like you can use constexpr functions to make expensive shit done at compile time, but then you have to somehow save it, or yeah, like you could have a constexpr global variable that's I guess maybe an array is how it would be, like a big list of information, like multiple data points, like 5, 10, 23, 68, 48 million, etc. And you calculate that whole thing by looping through a function and appending that information onto the end of it. And then later on, you just have something look at that piece of information. Okay. When should we do it? excuse me, if it can be evaluated as part of a required constant expression. What are you talking about? Meaning if a constant expression is required, doesn't that mean it must? Doesn't that mean must? If a function is evaluated as part of a required constant expression, like I'm initializing some constant expression variable with a constant expression function, and that constant expression function is being used in that context that requires it to be evaluated at compile time, and it's calling non-constant expression functions, yeah, those functions must be made constant expression, otherwise it's ill-formed, right? Or at least in most cases. I guess that's what they're saying. If there's one case that's constant expression, but the others aren't, it might still be okay. But seems like you just make them all constant expression if they're in a constant expression thing. A pure function always returns the same result with the same arguments. Okay. No side effects. All it does is take some information, return a value. Like in Unreal Engine, I guess that's a pure function. Get forward vector. Well, all you do is pass it some object. It does some sort of thing to check the angle. Like here's an object. All it does is say, hey, where are we in the world? Oh, all right, there's the forward vector. That's at this degree and this degree from the character. Boom. And it returns that vector, or I guess that, well, yeah, I guess it is that vector. And then you could get the rotator and all that stuff. I guess right now I'm trying to wear multiple hats. Not necessarily at the same time, though, so that way I can dive into things with as much detail as possible. Like right now I need to get a job involved in programming, that way I could just get better at solving problems and get paid more money. And I already have some experience in Unreal Engine, and mainly just Unreal Engine and Blender, honestly. And it's just using Unreal Engine and using Blueprint bullshit. Using Blueprint, I'll just be more accurate. I don't need to add personal opinions. But now I need to learn shit that's lower level that creates Unreal Engine. 1, so I can use the engine better. 2, so I can do exactly what I want inside it. And 3, so I don't have to use Unreal Engine. I can use whatever the fuck I want. So right now I'm just learning basically a programming language that will empower me to solve problems in programming related contexts, which gaming is. Okay. Yeah, or getting the player character. You pass in, I don't even think you pass in anything. I think you maybe pass in an integer for which player character you want, and if you pass in 0, well, it returns the first player character, the 0th one. And then if you do 1, it passes the second one, 2 for the third one, etc. Or, that's fine. They don't always need to be pure. Meaning, I mean, I could have a constant expression function that increments a global variable, right? Oh wait, well fuck, I can't make him constant though. But could I increment him if he's not constant? Fuck, I don't know. Maybe only if it's not used in a constant context. I don't know. Well, I guess it can't be const, huh? Um, hold on. Oh, the fuck am I doing? Oh, it's actually okay. Well, I guess it can't do that because it's at runtime. Yeah. Doesn't have to be pure because it had a side effect. Yeah, makes sense. Just depends on the context. True. Yeah, so if we have a function that's const expression, it's required to evaluate at compile time if called by another const expression function in a in compile time context, or just when called in compile time context. But if it isn't, if it's made not const expression, then it's no longer returning. It's no longer guaranteed to be made evaluatable, or it's no longer guaranteed to be evaluatable at compile time, or able to be forced to be evaluated at compile time. Therefore, we can't use it to initialize a const expression variable or call it by another const expression or const eval function that's being called in a const expression context. Oh, this is good. Is this recent? Yeah, Ling kind of locked in. Guess he's just not very good live. Yep. Well, it can still already be called by a const expression function. So this should be and, or this should be in a const expression context, or used in const, yeah, or used itself in that. Makes sense because then it's not a const expression returning function. Yeah, true. Makes sense. It's kind of scuffed.
Makes sense. Yeah, I mean, it's just removing code. It's just substituting values instead of calls, or for calls and whatnot, so it's smaller. Yeah, and you could still do it later. So, like, what would be an example of that? Yeah, like maybe in the game we a new level is created and the shaders for that must be calculated, or must be calculated at runtime. So there might be a context where we calculate the shader information before actually running the program, and other things use that information. But later, maybe we don't have enough memory to just store that shit. So maybe we actually, or maybe there's information that's found at runtime that affects this. So like if you're making your own world and the shaders are created automatically depending on the world, well, it depends on how the user makes the world, right? Because the world's only made at runtime by the user. Yep. Yeah, I agree. I cannot wait to learn classes. I'm gonna make Liar's Bar after. Yeah, agreed. Okay. Oh shit. Yep. Yep. Okay. I don't like copying code. I really hate copying code. Oops. Okay. Excuse me. Get tower height, I don't think. I mean, it could at least be const so the tower height can't be changed, right? But it can't be const expression because we have standard character input that's happening and character output too. Yeah, sure. can't be const because we're also changing this too. I don't think anything else can be changed here. I mean, I don't know if we care. I mean, these... I mean, maybe we don't want... I don't know if doing this would be helpful. Trying to do the functions here. What was this? Compound data types? Oh, fuck yes. I think we get structs. It's what I want. I don't even know if I need classes then, actually. I just need to create a player, and a player has different stuff, and then I can update that. Maybe that's how it works, actually. Structs might be what I need. Calculate ball height. Oh yeah, but if we make him const expression... Hold on. Then it can still be called at runtime. But it's only going to be called in print calculated ball height though. But if we compile this, we have to specify the tower height. So first we're getting tower height, but if we already have tower height, and we're just passing a tower height, but tower height, I mean, it can't be const expression, but it can be const. Right? I mean, if we did const expression, yeah, it's not a constant. Because it's evaluated to be the return type of get tower height, which can't be const expression. I mean, I don't think this would. We may as well, I mean, gravity may as well already be const expression. Distance fallen might be. We can say if you're a foot above the ground, after 10 seconds you would have fallen some amount of feet, but we can catch it. So if you hit the ground, we can, alright, yeah, I think this is okay. No? Why is this? Is this because seconds? Calculate ball height. Okay. Current height can't because tower height isn't known until... The point is that this guy, if he's const expression, that's fine. Const doesn't change anything here. I mean, maybe we don't want to change seconds here. I mean, I guess, right? Since we call it... Okay. I mean, same thing here. Double height, or tower height as well, what? I mean, we don't want to change it, so I think same thing. I mean, right? Right? Yep. I think that's all we can do here. What about print ball height? Might be all we can do too. I mean... Same thing. Seems like, yeah, like right now this doesn't make sense really to be const expression. I mean, maybe it does something, maybe it's optimized in some sort of way, but I don't see it. Because current height is dependent upon tower height, so. Same thing here. feel like that might be all. Alright, well, I guess I'll continue this in a sec. Alright. 30 more minutes off. Okay, time to upload.